Swayam Prabha. Digital India. Educated India.
Friends, welcome to the third class on GPS surveying. Today's class I will discuss on GPS signal. GPS signal I will discuss under three heads: carrier waves, GPS pseudorandom noise code and navigational data. Now users, we do receive GPS signal from GPS satellite vehicles, and then these GPS signals are we process to extract the information of our requirement. These GPS signals are actually some modulated carrier waves, and it contains different types of carrier waves, different types of codes as well as different types of navigational data. And as a user, what we do try to extract the information or data which we want to extract or we want to derive. So we need to know thoroughly the contents of any GPS signal. So there lies the need of this class, that we need to know as well as understand the contents of a GPS signal. Now GPS signal is the modulated carrier wave consisting of carrier wave which is sinusoidal in nature, then it contains binary type of pseudorandom code and also binary type of nav data. So sinusoidal carrier waves, binary pseudorandom noise code and binary navigational data. Now what it is done, first this PRN code and data gets added through modulo to addition, and then these two get modulated to carrier wave. As a result, we get the modulated GPS signal. Now the carrier waves are used for or helps in transmitting the GPS signal from satellites to the receiver without getting it lost in the atmosphere. The primary function of PRN code is to provide the identification of the signal, that means from which satellite it is coming, and then data is the primary object or primary information which users will make use to derive many important information for which this signal we are receiving. Now there are different types of carrier waves that is available in a GPS signal. This from beginning GPS satellites are transmitting the L1 and L2 carrier waves, and later this L2 is also associated with one more civil signal, that is called L2C signal, that is in quadrature phase and that is in phase. And nowadays the signal L5 is also available from latest GPS satellites. So in short, if we see to the defined signals, we will see that L1, CA, L2C and L5, these are the three civil signals available for users to use. Now let us discuss on these carrier civil waves. First it is L1. Now L1 signal is having the frequency of 1575.42 megahertz. This signal contains two types of codes. In phase it is the P code, or for civilian it is the PY code, and in quadrature phase it is the CA code. And the L1 with CA code is having more power than the L1 with P or PY code. So this civilian signal is more powerful. Next it is the L2 signal. L2 signal is having the frequency of 1227.60 megahertz. However, the content of L2 signal will depend upon the satellite from which this signal is coming. Now in phase, the L2 signal may contain PY signal with nav data, P or PY signal with or without nav data, and CA signal with nav data. So we can say L2 plus P or PY. P again, it may be P with or P plus nav, PY or PY plus nav, or CA plus nav. So which of this combination 1, 2, 3, 4, 5, which one will be available in a particular signal, it will depend upon from which satellite this signal is coming. Now in quadrature phase, there may be three combinations like L2 with plus, it may be CA plus nav data, or CM plus nav data, or CL. So out of these three, only one type will be available. Now this part of the L2 signal is also known as L2C signal, which is called second civilian signal. Second civilian signal. Now This L2C signal is more powerful than the L1C signal. So L2C signal can be or will be more available more under tree. However, L2C signal provides position having 65% more uncertainty than what the L1CA signal will provide. So if we want to walk under tree or little shade of tree, then we will go for L2C signal, but if we want to have our position more accurately, then we will go for L1CA signal. Of course, if we have the capability to capture both of them, then that will be still better, because that will not only L2C plus L1CA, both will provide us the measurement for ionospheric error, which is the worst type of error that is available in GPS signal, and once we can measure the ionospheric error, we will be remove it from our measurement. So that is the advantage of having two civil signals. Then our L5 signal, which is having the frequency of the order of 1176.45 megahertz. Again, the contents of L5 signal will depend upon the satellite from which we will get this signal. Now again in L5 also, in phase, the L5 signal will be associated with the I5 code and data. And in quadrature phase, the L5 signal will be associated with the Q5 code only. So it will not be having any data. However, L5 signal is more powerful than L1CA signal as well as also L2C signal. Not only that, L5 signal also having capability of wider bandwidth or longer spreading codes. So L5 signal is the most advanced and developed signal. So L5 signal along with L1CA signal and L2C signal, these three signal together provides a very robust signals for civilian use. Now we can see there are three civil signals, L5, L1, CA and L2C, and all these three signal has its own advantage and domain of application. Like L1 signal, which is having the maximum L1 CA, this is the signal which is having the maximum frequency. So this is having the least ionospheric error. So it will provide us very good position. Then L2C signal is having the best cross correlation performance, and L5 signal is most powerful and its frequency works in the range of ARNS, which stands for Aeronautical Radio Navigation Service band. That means this L5 signal is most useful for aero navigation. It provides it's also powerful, so aero navigation becomes easy with L5 signal. So with this we can now look into the part of navigational code, PRN, pseudo-random noise code or ranging code. It has different name. The most important function of PRN code is it provides identification to the signal. But another more important, not less than identification, is that PRN code provides the basic framework to acquire the signal by user. So acquisition of GPS signal is possible because of the nature of PRN code. Further, PRN code is also it is acquisition of GPS signal by user. Number 3, PRN code provides the time measurement. So these are the 3 important work that the pseudo-random noise code provides to user. In GPS signal there are 6 types of PRN codes that are available, which are the most important. Initially it has been the P code or precise code, which is fundamentally has been developed for the military purpose, but later it is being opened for civilian, but it has been encrypted with another code which is W code, so which is a 20 bits per second code, and with this a deformed PY code is made available for the civilian use. Then it is the course acquisition code, CA code, course acquisition code. Then for the civilian code it is the CM, civil moderate code. Then your CL, civil long code. Then 5 I5 code for the L5 signal, and then Q5. So there are 6 types of codes that is available for civilians to use. Of course, P code is not for civilian use, it is the PY code which is useful for which civilian can get access to. CA code, CM code, CL code, I5 code and Q5 code. Now let me start with the P code or precision code. The P code or precision code, actually it is developed for the military use, but for civilians it is the PY code. As I told you, PY code is nothing but a P code encrypted with another code called W code, and this P code is having the chipping rate 10.23 megahertz, whereas the W code is having 20 bits per second. So these two will give you the PY code, and this PY code is having the chip rate what is available for P code, that is what is the chipping rate of PY code, and having your chip length 29.3 meter, that means with P code only theoretically we can arrive at an accuracy of 29.3 meter. However, at present we have many improved algorithm, so we can achieve much more better accuracy than this. Now these P codes are having period of 7 days. That means the same code repeats after 7 days, and these 7 days, the first day, the 0 day starts at 0 hour between Saturday and Sunday. So 0 hour, and generally we tell it like 12 hour at night, which is the 0 hour. 0 hour from Saturday to Sunday, that means 0 hour of Sunday is the time when the P code starts, and the code continues and again it restarts in the next 0 hour of Sunday. So it is called 7 day, and each code, that means from particular satellite, particular 7 days code they use, so that 7 days code also identifies the satellite vehicle. Satellite vehicle is also identified by the week number of the P code which has been assigned to that particular satellites. Next, it is the CA code. CA code means course acquisition code. Actually, this is the most important code because the acquisition of GPS signal starts with this code, and this provides the identification of the signal. It also provides the measurement of time first, and it helps in acquiring the signal. Now the chip length is chip frequency, chipping rate is 1.023 megahertz, that means 1/10 of what P code is, and its chip length is 293 meter. So this is the accuracy, raw accuracy that we can achieve using the CA code, and each satellite have individual CA code or particular CA code which provides the identification of this code. And another thing, the period of this code is 1 millisecond, that means at 10 to the power minus 3 second interval this code repeats. Next, civil code. As I told you, civil codes are available with the L2CC signal, which is the L2 signal in quadrature phase. Now this civil signal, that means in phase it is the that means with the L2C signal will be in the quadrature phase of the L2 signal, and this will be having that CM civil moderate and CL code civil long. It is having 10,230 chips, and the civil long having 7,67,250 chips. So it is of moderate length and having the accuracy same as what P code provides. So, CM code is equivalent to PA code of military signal. And CM code is also provided with the navigational data, but our CL code does not have any navigational data. Next, it is the I5 or Q5 codes. These two codes are available with the L5 signal. As I have told you, the I5 codes are available in phase with the L5 signal, whereas Q5 code is available in the quadrature phase. And also I5 signal is associated with the data, nav data, but there is no data available with the Q5 code. Now the I5 and Q5 code is having chip rate 10.23 megahertz. So as it is a P code and its PRN code sequence is 10.23Z. Now one thing which is unique to these I5 and Q5 code is that they are associated with a PRN code known as Newman-Huffman code, which is having the chipping rate 1 kilohertz, and it is a 10 bit for I5 and 20 bit or for Q5. Now this Newman-Huffman code is added to I5 and Q5 for better separation, bit synchronization, and there are three functions that this does. One is that it provides better separation, it provides better synchronization, and most importantly this Newman-Huffman codes obstructs the GPS signals to get interfered with other narrowband signals. This is the most important thing. So I5 L5 signal is considered to be very powerful and very useful for the civilian use. So with this I want to talk next on navigational data. Actually navigational data is the most important information navigation data. This is the most important part for user, because user look for navigational data. Now before I go what is its content, let me first see that how many actually navigational data that is available from in different parts of the GPS signals are not same. For L1 and L2 signals, this navigational data is of variety known as LNAV, that means legacy navigational data, whereas the navigational data that is available with the civil signal L2C, it is the CNAP. So, it is called civil navigational data. Now, in case of I5, because Q5 do not have any data, navigation data, I5 it is also civil navigational data, but of different variety. So modified civil navigation data. Now, what is the significance of this? The significance of this information is that while we will process the GPS data, we should not make use of all these signal together. Only we will be able to process the signals which having the identical type of navigation data. This is the most important part. Now, what is the use of navigation data? Now, the navigation data, actually the navigation data contains a plethora of information about the satellites, its orbits, about satellite, about orbits, about the atmosphere through which it is coming, and many other. So, now the information about the orbits will provide the position of the satellites at the particular time of transmission of the signal. Now, satellite information provides you the health of the satellites and the subsequently the quality of the data that has been received by the user, and this atmospheric information and many other informations which will also provides us about information about the quality of data and other information. So, and to summarize, we can say like that, actually as a user we are in need to have the navigational data from the satellites. In order to get the navigational data, the identification of the data from which the data is coming from particular satellites, PRN codes are used, and to these two data is having very low energy because these two are in binary format, and so if we have to get the data from satellites to receiver through such a huge distance of about 20,000 kilometers, we need to provide enough energy to this part of the information, which is being done by making use of carrier waves. So, these three makes are the GPS signals which has been discussed in this class, and in the next class we will be discussing on GPS receiver. Thank you.